We're talking about equations, ODEs, where we have missing variables. So whenever we have two variables in any ODE, we have the dependent variable y, it is the dependent one, and we have the independent one x. What happens when y is not in an ODE, or what happens when x is not in an ODE? The use of substitution we are going to be talking about in this video. So the first one is when x, okay, looking at this, x is present, but there's no y. So there's no y here, y is absent, y is absent. But in this one, even x is absent here. Both of them are absent. So let's take this as x is absent. So whenever you first look for x, if x is absent, you just take it as that. So x should be our main priority. So what happens when y is absent? What happens when x is absent? So for y, for both of them, when y or x is absent, we are going to use our substitution v. Let v equals to what? dy dx. When both of them or either of them is absent, we are going to use this substitution. But what's the difference? When y is absent, y is not, if y is not there, we are going to use our v as a function of x. When x is not there, we are going to use our v as a function of y. You get what I'm saying? When y is absent, for this one now, we are going to use the substitution v is a function of x. When x is absent, we are going to use our substitution v is a function of y. So let's attempt the first question. Y is absent, so we are using our v as a function of x, which means v of x equals to what? Dy dx. And our second derivative, the square y dx squared, the square y dx squared is just equal to what? Is equal to v prime of x. That's the v dx. The v dx. These are the square y dx squared. So we are going to be plugging this into the ODE. Don't forget the square y dx squared is same thing as y double prime. Don't forget that. So let's plug it into this ODE. We have x into bracket. Instead of writing y double prime, I write my v prime. Equals to 2. Now y prime, what's y prime? Y prime is the y dx. Y prime is the y dx. 2v into bracket v minus 1. So I have something like x v prime equals to 2v into bracket v minus 1. So what am I going to do whenever I have something like this? I'm going to turn this into, this is a separate equation we have in terms of v and in terms of x. This is the same thing as writing x dv dx equals to 2v into bracket v minus 1. So I can separate this and say dv over everything that is here, I bring it to this side, over 2v into bracket v minus 1 equals to dx will come up, x will come down, over x, and I integrate both sides with respect to whatever they are to be integrated. So now let's integrate this. We have integral of, let me clean this please. Okay. So we want to integrate this. The integral of dv over 2v into bracket v minus 1 equals to the integral of dx over x. This side I can easily integrate it and say equals to ln x plus c. But this side, we are going to integrate it using partial fraction. So we are going to have something like a over 2v plus b over v minus 1, right? So I can easily write this out without wasting much of our time. I hope we are good with partial fraction, please. So I'm going to write this as a into bracket v minus 1 plus, so we are going to be, let's not waste our energy. We can easily factorize this one out. Like we can bring over 2, we can bring it outside. So we are going to rewrite this ODE as, let me clean this 2, so as to make the work easier. We have 1 over 2. 1 over 2 is the same thing as what we have been doing before. So now let's integrate this. We have a over v plus b over v minus 1. So it is going to give us something like a into bracket v minus 1, a times this, b times this, plus bv, and it must be equal to 1, since our what is up here is 1. So it must be equal to 1. That means av minus a plus bv equals to 1. Let's compare. Av plus bv, there is no function of v here, so we have is equal to 0, minus a equals to 1, which means a equals to minus 1. right? Minus a is our constant here. The only constant here too is 1. So minus a equals to 1, a equals to minus 1. So now let's solve this. A, if I divide through by v, a plus b equals to 0. Don't forget a is minus 1, which means minus 1 plus b equals to 0. Therefore, b equals to 1, a equals to minus 1. So I can have this as the 1 over 2 integral of what? A, which is minus 1, over v plus, what was my b? B is 1 over v minus 1. We are integrating everything here with respect to the v. We are integrating everything here with respect to the v. So I have, integrating this one, I have 1 over 2 minus, bracket it. If we integrate this, we have minus ln v plus, if we integrate this one, we have plus ln v minus 1 equals to, we have integrated the other side, equals to ln x plus c. Now let's open this bracket, or no, let us multiply 2 by 2. Since everything here owns this 2, so we can multiply 2 by 2. So we have 2 times this equals to 2 times this side. 2 we cancel out 2 here, we have, I can rearrange this one and say ln v minus 1 minus ln v equals to 2 ln x plus 2c. 2 ln x plus 2c. Now, since 2c is an arbitrary constant, c is an arbitrary constant, 2c can also be written as c. So I can write 2c as c, since it's an arbitrary constant. Or I can say this one is still 1c2, which does not matter actually. Which does not matter. So I'm going to have something like this. Now, don't forget, ln a minus ln b is the same thing as ln a over b. Ln a plus ln b equals to something as ln, the same thing as ln a b. So this side I can write this one too and say ln a minus ln b, I have ln b minus 1 over v equals to, I can write this as ln x squared plus ln c, and equivalent, it is equivalent to ln cx squared. Don't forget, this is just an arbitrary constant. I can write it in any form I want. It's an arbitrary constant, so I can write it in form of ln c. Ln c is also a constant. So I have addition of two logarithms. We have ln x squared plus ln c will give us ln x squared times c, which is cx squared. Now we have this ln v minus 1 over v equals to ln cx squared, which means if we raise both to the power of v, both of these lns will go out, which means v minus 1 over v is equivalent to cx squared. It's equivalent to cx squared. So continuing with that, we can make this look like, if we divide both of them by v, we are going to have 1 minus 1 over v. V divided by v is 1, minus 1 over v, I separated it, is equal to cx squared. So I can bring this to the other side and this to the other side. So I'm going to have something like 1 over v, taking this to the other side, bringing this to the other side, equal to cx squared will be negative plus 1. So that's 1 over v equals to 1 minus cx squared. Now don't forget from the onstart, the most important thing you must not forget, what is v itself? V is a function of x and y here. So v equals to dy dx. Our v is a function of x, v equals to dy dx, which means 1 over v equals to what? Dx dy. So I can write this as 1 over v is dx dy equals to 1 minus cx squared. So dy dx equals to what? Dy dx equals to 1 over 1 minus cx squared. So dy dx equals to 1 over y, dy dx equals to 1 over 1 minus cx squared. So what do? We separate this again, which means the y equals to dx over 1 minus cx squared. So we integrate both sides to get y equals to what? The integral of dx over 1 minus cx squared. So how do we integrate this to get our final answer for y? So to get our final answer for y for this one, we are going to rewrite this as a, don't forget, 1 minus cx squared can be written as 1 squared minus root cx squared. Difference of squares. If I open this bracket, I have cx squared back. Difference of squares. So I'm going to have 1 minus root cx, 1 plus root cx. So I can write this as y equals to what? Integral of dx over 1 squared, or let me just write it out like this, 1 minus root cx, 1 plus root cx. 1 plus root cx. So if I'm to integrate this, I'm going to use partial fraction, and I'm going to use something like a over 1 minus root cx plus b over 1 plus root cx. So if I do this, I have a times everything here. That's a times 1 is a plus a root cx plus b multiplied by everything here. B times 1 is b minus b root cx must be equal to the coefficient of this dx is 1. Is equal to 1. So every constant here must be equal to 1. A plus b equals to 1. A root cx plus, okay, there's minus here, minus b root cx, there's no function of x here, equals to 0. So if I divide everything through by root cx, we have a minus b equals to 0, which means a equals to b. So going to this, I can replace this a as b. So I have b plus b, that is 2b equals to 1. So 2b equals to 1. This equivalently means b equals to 1 over 2. But don't forget a is equal to b. That means a is also equal to 1 over 2. I purposely skip some steps to make this video shorter. If you don't understand any part of partial fraction, there are other partial fraction videos on this on the channel which Velo has done. Make sure you watch them if you don't really understand partial fractions in details, so you will not miss out on how I did everything. A plus whatever plus whatever. Go and watch Velo's other videos on partial fractions. So we have gotten our a and our b as a equals to b, and both of them are equal to 1 over 2. Now let us integrate this finally. Let us integrate this. So y equals to, we have separated this, we have used partial fraction to separate this as a over 1 minus root cx plus b over 1 plus root cx. Everything is dx. Everything, both of them, dx. So we have gotten our a to be 1 over 2. And our b is also 1 over 2. So I can basically rewrite both of them and bring 1 over 2 out. 1, 1. Right? Yes. So I can basically bring both of them out and say 1 over 2 comes out. So y equals to what? Y equals to 1 over 2. Now I want to integrate this. Now, the integral of this, if you notice, if we differentiate this, the only thing that will remain is a constant, which is minus root c, sorry. So it means I can multiply both of this one by minus root c over minus root c. Both of them can cancel out to make 1. It does not affect our equation. For this one, if I differentiate this, I will get root c, which is also a constant. So I can multiply both sides by root c over root c. If you don't understand this part, you can also watch other videos on integration. They are on this channel. So this one, if I differentiate this, it is going to give this one. So I can bring this one out and say 1 over minus root c. If I differentiate this, I get this ln 1 minus root cx plus, if I differentiate this, I get this. So this one is coming as 1 over root c ln, if I differentiate this, I get this 1 plus root cx. Okay. Now, don't forget what we talked about as per our, okay, let me bring out this. Since 1 over root c is common to both of them, let me bring it out. Y equals to 1 over 2 root c. I can now write this one first as ln 1 plus root cx minus, there's minus here, minus ln 1 minus root cx. Don't forget what we talked about as ln. The addition of ln will give us this, subtraction of ln will give us this. So I can write this as y equals to what? Y equals to 1 over 2 root c ln everything here, 1 plus root cx over 1 minus root cx. Since what I did was subtraction. So we have something like this, and this will be the final solution to our ODE. So this is the final solution to question number 1. Y equals 1 over 2 root c ln 1 plus root cx over 1 minus rho cx. We can add our plus c, our constant of integration, plus c, and that's the final solution to this ODE. But the main thing you need to know is not about all these steps, it's not about all this, is to know what to do exactly when you see this kind of equation. When your y is absent, what do? You are going to use a v, which is a function of x. Y is the one that is absent. We are using a v, which is a function of x, and it is equal to the y dx. Is equal to the y dx. Now let's go to the second case in which x is the. So we are done with the first one. Now let's go to the second one where x is the one that is absent. We have y, we don't have x. So since we don't have x in this context, when we don't have y, v is a function of x. When we don't have x, v is a function of y and is equal to the y dx. So if we differentiate this, when we are looking for our second derivative, the square y dx squared will now be equal to v dv dy. Since v is a function of y, our second derivative will be v dv dy. So we are going to substitute this into the equation. So we are going to have something like y dot our second derivative, which is v dv dy, equals to y prime. What's y prime? Y prime is the y dx, which is v into bracket v plus 2. Our dy dx is v. So we have this. Now there's v on this side, there's v on this side. We can cancel it out and say y dv dy equals to v plus 2. Now this is a separable equation. We have y over dy. I can take this under here equals to what? V plus 2 over dv. Separable equations. You can watch the videos on separable equation for this. So now we can now transpose this and say dy over y equals to dv over v plus 2. Now integrate both sides with respect to whatever they are to be integrated. So we are going to have something like ln y equals to ln v plus 2. Since v plus 2, if I differentiate it, I get 1. So ln v plus 2 plus c. So I can say, instead of writing c, I can write it as, okay, let me write it as c, it does not matter. So my y is going to be equal to integral e raised power everything here. So we have e raised power, this is going to give me v plus 2 into bracket a, or to make it easier for those of us that might just be learning this. So I'm raising both sides to the power of e. E cancels this ln, right? So it means my y equals to what? Y equals to e raised power ln v. I can write it as e raised power ln v plus 2 plus c. This plus c, I can now write it as times. Don't forget this is e raised power c. I can take it as a. Take it as a. So a is coming to the other side, and we have y equals to a e raised power ln v plus 2. E cancels ln, so y equals what? V plus 2 comes down. A is bracket v plus 2. So this is my, oh, yes, this is my y equals to this. But we are looking for y in terms of x, not v. We are looking for y in terms of x. So I can write this as dividing both sides by a. Don't forget, 1 over a is an arbitrary constant. So it's equivalent to not equal to a. So I can write it as ay equals to what? V plus 2. Bring my 2 to the other side. I have ay minus 2 equals to v. So v is the same thing as the y dx. V is a function of y, which is correct for this. V equals to ay minus 2. So if the y dx equals to ay minus 2, let me use this side. So if the y dx equals to ay minus 2, it means I can separate these two and say the y over ay minus 2 equals to what? Equals to dx. And I integrate both sides. If I integrate this, if I differentiate what's under, I'm going to get only a. So I can multiply up and down with a. So I use a over a, right? This one will come out. So I have 1 over a ln ay minus 2 equals to x plus c. Right? Yes. So I can now multiply through by a and say this one will leave here and say ln ay minus 2 equals to ax plus ca. But both of them are what? Both of them are constant. So I can just write it as what? I can still write it as, let's say, C2. I can write it as C2. So whatever is here equals to this. So I raise both to the power of E to make my y stand alone. So I'm going to have ay minus 2 equals to e raised power ax. So let me write my ax as a small something. What? Ax plus c2. Now you know what? A is a constant, is an arbitrary constant, c2 is an arbitrary constant. Let me write it as both of them as a. So I can now rewrite this as ay minus 2 equals to e raised power. Since we are using this a here and this is the same a we are using here, I can just say both of them are capital letters a. E raised power a into bracket x plus 1 is still the same thing. What we are doing is still the same thing, it's still valid. So what I have now will be y minus 2 equals to e raised power a, let me write it as a small a into bracket x, or let me write it as ax plus a. So as law of indices says, I can write it as e raised power a like this. So I can just say this is my a. Or, not to make it hard for those of us that are coming along, let me start from here once again. Let me start from here. So we have 1 over a ln everything that is here. Now let's multiply through by a. So I'm going to have something like ln ay minus 2. Ln ay minus 2 equals to ax plus another, let's just call it is an arbitrary constant. Since a is an arbitrary constant, this one too is an arbitrary constant. I can write it as ln ay minus 2 equals to a into bracket x plus 1. A into bracket x plus 1 since it's an arbitrary constant. So now ay equals to what? Ay minus 2 equals to e raised power a into bracket x plus 1. So it means ay equals to 2 plus e raised power, let's just call it e raised power ax plus a. So this one can come down and come here. An arbitrary constant. So I have y equals to, dividing everything by a, 2 over a plus a will cancel out a, e raised power ax. So I can call this another arbitrary constant and say my y final answer equals to what? E raised power ax plus c2. Plus c2. Anyhow, plus c2. So y equals to, this is the final answer for the second ODE. So the first one, y is missing. So we use v as a function of x since y is missing. For the second one, we use v as a function of y since x is the one that is missing, and that's how we solve ODEs with missing variables. Whenever y is absent, use v equals to the y dx. Whenever x is absent, whenever both of them are absent, we use v as a v equals to the y dx. But the difference is that x is absent in this one, we use it as a function of y is absent in this one, we use it as a function of x, and that's what makes them different. So that's how to solve ODEs that have missing variables. Thanks for watching this video. Make sure you like and share. See you in the next